Hello class. Today we'll be going into chapter 5.2, solving simultaneous linear equations in two variables by graphical method. On your first page, you will see this graph here with two lines on it. Okay, for the first question, it asks us to plot the points A, which is at 2 and 4, okay, which will be here. Always remember to read the x-axis before the y-axis when reading coordinates. Okay, then point B is 1, -1. So similarly, we'll look at the x-axis first before the y-axis. Therefore, point B will be here. Lastly, we want point C, which is 5, 1. So x-axis will give us this point and y-axis will give us this point. Alright, so with this, in question 2, it asks us to complete the following table. It wants us to tell them whether points A, B, and C are solutions of the lines x plus y equals to 6 and x minus 2y equals to 3. So let's look at point A. From what we have marked out earlier on, point A is over here. We notice that point A lies only on x plus y equals to 6, but not x minus 2y equals to 3. Whereas for point B, which is down here, it lies on the line x minus 2y equals to 3, but it does not lie on the line x plus y equals to 6. For point C, which is over here, you notice that it lies on both the lines. So we'll answer yes to both the lines. So how are the points A, B, and C related to the lines? As mentioned, point A is a point on the line x plus y equals to 6, but not of the line x minus 2y equals to 3. Point B is a point on the line x minus 2y equals to 3, but not of the line x plus x plus y equals to 6. Lastly, point C is a point on both of the lines. Okay, in question 4, it wants us to identify the common point that both of the lines above pass through. How are the coordinates of the common point related to the lines? So, we have identified earlier on that point C lies on both of the lines. So we'll write here point C and bracket the coordinates 5, 1. We say that it is the point of intersection of the two graphs, since it lies on both of the graphs. Okay, now study the graphs. How many solutions are there satisfying both equations x plus y equals to 6 and x minus 2y equals to 3? What is or are the solutions? So, we know that only point C out of points A, B, and C is a point that lies on both the graphs. Hence, we say that there is one solution, which is our point C. When they ask what are the solutions, we have to give them the set of solutions x and y. Okay, nonetheless, it is considered as one solution. We consider it as one set of solution. Alright, so in this case, we are looking at the coordinates of point C. So we have x equals to 5 and y equals to 1. Okay, moving on. Okay, hence, when we have a system of two linear equations called simultaneous linear equations in two variables x and y, it means that these two equations actually have it has a value or solution that is common to both of these equations. Alright, so hence if a solution exists, it is the pair of coordinates of the point of intersection of the graphs. So in the previous example, the point of intersection was point C. where the graphs cut each other. Okay, let's look at example 1 now. We're given two equations, x minus y equals to 2 and x plus y equals to 6. The question requires us to solve these two equations graphically, which means that we have to draw the lines for both of these equations. So let's look at the first one, x minus y equals to 2. First of all, we need to complete the table. So what we can do is to move your y over to the right, and you have y equals to x minus 2. With that, you'll be able to solve the equation. Double check if your numbers are correct by substituting it back into the equations. Once you have your table done, you can now plot the points. So the line x minus y equals to 2 will look something like this. Where it passes through this the 3 points that you have identified earlier on in the table. Okay, next for x plus y equals to 6. Similarly, y would be equal to 6 minus x when we move x to the right. Hence, you'll derive at this corresponding values for y. Now we'll have to plot the graph. Okay, once again, we plot the 3 coordinates first before we join it with a straight line. Now, when the question asks us to solve the simultaneous equation, we are trying to find where is the point of intersection, because that will be our solution. So, we have a point of intersection over here. To find the coordinates, draw dotted lines. So we'll see that the x value will be 4 and the y value would be 2. Okay, so write down your answers. Okay, next we'll move on to the homework section. Please take note, this is not example 2. This is the homework section. Okay, we are looking at the second question of the homework section, which is on the last page of your notes. Okay, in question 2, it asks us to solve the simultaneous equations graphically. 3x plus 4y equals to 12 and 6x plus 8y equals to 9. Similarly, fill up the table first. To do so, what you can do is to move your 3x to the right hand side. So you have a negative 3x plus 12. And here I'm dividing by 4 because I have 4y over here, but I only want my y. So by doing so, you will have the equation in the y equals to mx plus c format. So here, calculating this, we will have these 3 sets of y values. And with this, once again, we will plot the graph. So plot your 3 points, join it with a straight line with a ruler, and don't forget to label your graph. This is important because in simultaneous equations graphs, you have 2 graphs and we will need to know which graph belongs to which equation. Okay, next, we have 6x plus 8y equals to 9. So we want to find what is y. We will move 6x over to the right, hence giving negative 6x plus 9. And then we'll have to divide by 8 to get 1y instead of 8y. Right? So this can be simplified into negative 3 over 4x plus 9 over 8. Negative 3 over 4 derives from negative 6 over 8 in the previous step. Hence with this, we can calculate. You notice that the numbers are not very nice whole numbers. Alright, so it is going to be a little tricky to draw on this graph given the limitations of the scale. Alright, nonetheless, we are going to estimate it. Okay, so when you draw the points in, you'll notice that the graph looks something like this. Okay, in this case, you'll notice that the graphs do not cut each other. If we look back at the equations in the y equals to mx plus c format, we'll notice that m, which is my gradient, is negative 3/4 in the first equation, and it is also negative 3/4 in the second equation. What this means is that both the graphs share the same gradient. When two graphs share the same gradient, it means that they run parallel to each other. If two lines are parallel to each other, there can be no solutions because these two parallel lines can never cut each other. Hence, for our answer, we'll say that there are no values for x and y. There's no solution to this question. Alright, so we'll state that there are no solutions as the lines are parallel. Both of them have the same gradient of negative 3/4. Okay, with this, I would like you to try example 2 of your notes on page 4 and also homework question 1 on page 5.